In the previous videos, we have covered the mappings in a function, and we have seen that for a function there are two types of mapping, many one and one. And based on the mapping, so we have two types of function, many one function and one function. And this is because very simply, for every element in your domain, or because if your function is from set A to B, then for every means mapping is from set A to set B. Because every element of A is uniquely mapped, there is only one edge that comes out of A. So it might happen that all of them are going to different elements in B, then it is one mapping. And if it happens that you have some of these lines going to the same element, then it is a many one mapping. Now, but when it comes to general relation, just I'm not talking about a special relation of that is function, which is constrained that every element is uniquely mapped. I'm just talking about the general relation R, which is from A to B. From individual element of A, possibilities for any element of A is that it is not mapped at all. That is, it does not contribute in the ordered pair of a relation. This is one of the possibility. Another possibility is that it contributes in the ordered pairs, and it contributes in more than one ordered pair. That is, it is not uniquely mapped. So it may happen. Let's say if this is my set A, then for any arbitrary element, let's say A1, so it might happen that R does not have any ordered pair with A1 as its first element. That is, A1 is not mapped at all. Let's say there's another element A2, and this is uniquely mapped to some element, let's say B2. Then we have an ordered pair like A2, B2. And let's say you have an element A3, and this element may be mapped to multiple elements. Okay, B1, B3. And then this will contribute A3B1, A3B2, A3B3. So when it comes to function relation, a lot of things are possible. Consider A3. There may be a lot of such A3s. Means lot of elements in A that have this thing, the multiple lines going out. So it is like if you just take up, let's say if you take up A4 also, and A4 is mapped to B4, B5, B6. B4, B5, B6. So let's take a subset of A, which is just A3 and A4, and B completely. So a subset of A dash, which is A3 and A4. Subset of A dash, A3 and A4, and B as it is. A3 is mapped to B1, A3 is mapped to B1, B2, B3, B1, B2, B3. A4 is mapped to B4, B5, B6, B4, B5, B6. So what type of mapping you can say? What type of mapping it is? It is one to many mapping. Okay. Similarly, many to many type of mapping is also possible. Here, one element is mapped to many elements. Many to many means many elements are mapped to many elements. Okay, so there's mapping among many. So it's like a hodgepodge. Everything is possible in a function, in a relation, in a general relation. When it comes to mapping, anything is possible. I have just taken a subset to show you one to many. But in a given relation, when you have many elements in A, let's say A1 to AN, when you have too many elements and everything is going on at the same time, in calculus we just specifically deal with functions. Okay, so from the next video onwards we will see value of the function, limit of a function, because it's function that is uniquely mapped, and because of that uniquely mapped, for a given input you get a particular output. In calculus we will study things like limits, then continuity, differentiability. Main focus is on optimization, how to know when the function is at the highest value, when it is lowest value. All of those things is because the curve, the nature of the curve of a function is that when you draw a perpendicular line with respect to x-axis, then you are going to cut the curve at only one point. You have a definite value for a given y, for a given x, a definite y. So from next video, we will start calculus. Thank you very much.